All right, so let's continue. Last class I did this. Do you have any questions regarding this? Do you remember what this was? This was the manual method of finding the wavelengths. I'll just do a quick recap here. So last class we saw that using the double slit interference experiment, if you know the size here, which is A, if you know how far the screen is, which is D, and if you know the distance between two fringes called fringe separation, right? তুমি যদি একটা ফর্মুলাতে প্লেস করো তাহলে তুমি ওয়েভলেন্থ বের করতে পারো, wavelength of the source here, right? But this formula comes with a catch. You can't use this formula all the time. There's the requirement হচ্ছে খুবই strict. A has to be less than D. Okay, so এটা মানে হচ্ছে it has to be like 1,000 times smaller in size. If the ratio is 1,000 times smaller, then only this thing works. Otherwise, it doesn't work. Okay. So yeah, a formula is very limited. I think this MCQs actually so far. Recent papers, I have not seen them give this in structured paper. MCQ actually is kind of obvious, right? Ora ki kore MCQ te? Example day. MCQ te ora ki korbe? Ora ekhane ei purotar length ta bole dibe, like 20 centimeter. So fringe separation ki 20 hobe, or do I divide that by 4, or do I divide that by 5? Fringe separation যদি বের করতে চাই, if the whole thing is 20 here, right, a fringe separation would be how much? 20 divided by 4 or 20 divided by 5? 4, because fringe separation the gap below, how many gaps are there? 4. So okay, that's the only thing they do. But structure that's the manual method, and manual method is applicable when you're separation, and this is not in the household ratio. So do the 10 centimeter high, 30 centimeter high, we can like one use the formula. Right? Like you guys use the formula last method, different 3.7, right? Whereas it should be 3.5, it's a very different answer. So how do you do the math at 9, just you have sources here, right? So you find the distance from here to there, and you find the distance from here to there, and these two light going at this point is the force max, right? What does the force maximum mean or correspond to? But if force max may be 0.5, what does it mean? What's the significance of that? And the wavelength, the path difference. Yeah, the path difference is 4 lambda, which means that the length here and the length here is a difference of 4 lambda. So you can just find the difference, and then that will be 4 lambda, and that's how we found the wavelength, right? So it's a manual method, and it's a structured paper on often, and you get a lot of marks for it as well. Okay, students also struggle here. So I can club a manual method taking the important element now. So yeah, we will be wrapping up that chapter today with Shesha Digagdom. So Ashija Korbo, I will start diffraction gradient. That's the last part of our waste chapter. Okay. So double slit interference experiment question So double slit interference experiment, just quick recap, was this idea where you took a light source and you pass the light source to two gaps, right? As the light passed through the two gaps, what they did was they interfered, right? And they produced these bright and dark fringes bola hoy. The bright spots were because of constructive interferences, and the dark spots were because of destructive interferences, right? That is it. The requirement for this to happen, right, the interference pattern to take place, is that the wave needs to be coherent. Coherent মানে হচ্ছে they have to be same frequency, same wavelength, same everything, amplitude same now হলেও চলে. Okay, so that's what the requirement is, and that is it. Now, can this interference pattern take place with just light, or can it happen with any waves? Double slit interference pattern, dark and bright fringes. Is it only exclusive to light, or can it happen with any wave? Yes, the answer is it can happen with any waves. Okay, then why is the experiment done with light? So let me give you an insight here. Lighted experiment যদি করি এই room করা যাবে actually. Okay, so what will happen is you take a laser, you pass it through very small slit, screenটাকে 1 meter দূরে রাখবা, like that, এখানে তুমি প্যাটার্নটা দেখতে পারবা, and it actually happens very nicely. Okay, so the problem is if I replace light with sound, for example, right? How would I do this? So I'll take two sound sources, right, and pass them with same frequency, or I can take one sound source and pass it through a gap, right? Diffraction হবে. Sounder problemটা কি হচ্ছে, sounder a pattern যেটা form হয়, it's massive in size. So এই রুমের মধ্যে যদি আমি দুইটা sound source use করি এখানে, and I create a pattern here, the pattern would be like half the size of this building. Dark and brighter জায়গায় loud sound পাবা, no sound পাবা, loud sound পাবা, but it becomes very big in size. And তোমাদের exam জিজ্ঞেস করে why does that happen? It's an actual exam question. I don't know if you can notice here, a equation reveals to you why it happens. So if you look at this equation, a pattern, right, is which quantity in this equation? The pattern that forms the bright and dark and the bright and dark, right? X, very good. X is what the pattern size is, right? Now, A, D, এগুলা যদি fix থাকে, X এর কিসের উপর depend করে? Lambda. So sounder wavelength compared to lighter wavelength is a billion times larger. A billion times, because one is in the scale of nanometer, sound waves have wavelength in the size of meters, right? So এটা যদি 10 times এর জায়গায় 1 million time বেড়ে যায়, wouldn't this increase a million times? And once that increases million times, you'll find that they are separation of 10 meter, right? 10 meters, the size of this room. That's why we use light here, not sound. Okay, right. Anyways, sound is the question. There are plenty of questions with sound as well. I'll try to show a demonstration. I can't any catch this recently, but I'll see if I can bring it on. পরে দেখাচ্ছিল লোড হচ্ছে না। Okay, let's move on. আমরা এটা শেষ করে তারপর if time permits I'll come back here. So we'll start a new topic, last topic of our waste chapter. Can you go to page number 62? Page 62 তে যাও. It's a very small topic. আজকে শেষ হয়ে যাবে. Page 62. Right, it's called diffraction grating, and I would prefer just শুনো for the time being, কিছু লেখা নেই এরকম, just a formula that we'll be discussing, okay? কোনো derivation বা কিছু নাই. So what's a diffraction grating, and why do we use it, and what does it help us find, right? So diffraction grating is actually the name of a device. It's not a process, it's not a interaction, it's not a formula or theory, it's the name of a device. Device হচ্ছে a piece of glass. So diffraction grating is this very thin piece of glass, and this glass has slits in it, gaps in it, okay? So the thing about the diffraction grating is that it has these gaps in it, which are extremely small in size, and there are a lot of them out there, okay? So a typical glass would have over 1 million gaps in them. আমি যেটা draw করতেছি is obviously not even close, and in real life if I actually gave you this glass, it's there in the lab, a glass দেখলে you wouldn't even know if it's a different glass or not, because the lines are so small, right? It's not visible to your eye. So তুমি যখন notice করবা, you'll notice it's just a piece of glass, but what does it actually contain in it? Billions of these small lines in them, right? So there are these billions of lines out there, and they're all gaps that allow light to what as they pass through? Diffract. So light এটার ভিতরে যখন pass করবে, light diffract করবে. Now you know what the thought process was. Thought process ছিল যে Young's double slit interference থেকে আসে. So Young, what he found was that he could place two slits, right? একটা light source এদিক দিয়ে enter করবে, ওই light source এদিক দিয়ে enter করবে, and wouldn't the light source interfere with themselves, right? And what happens at the center? Is the brightness the same or double, right? So he thought, what if I have three gaps, like 1, 2, 3? Light এখানেও যাবে, সোজা যাবে, আবার এদিকেও যাবে. So what would the final intensity be? 3 times, you know? So he thought, what if I have like millions of gaps? What would happen, right? Would my light actually amplify a million times, right? Unfortunately, no, because you know the energy is eventually getting split up. So therefore, in terms of law of conservation of energy, the brightness can't be a million times brighter. However, the central part, like the central part of the thing, the spot, right, would be what brightness? Really bright. And you'll find that it turns white in color. When I have to light to that whatever color you use, red, green, blue, it becomes white. Like, you know, it's too bright for us. So what they found was that if you use a diffraction grating, this thing, right, with all these lines in them, and you pass light through it, right, এটা হয় যে মাঝখানে অনেক bright হয়ে যায়, and you still have the fringe pattern, but something unique happens. What happens is, let me show you here. So তুমি যদি এই glassটা নাও, this piece of glass, the diffraction grating, right, and you pass light through it, and as you pass light through it, light will diffract, right? And এখানে একটা screen যদি place করো, একটা pattern form হয়, and that pattern is very important for us. Pattern টা একটু বুঝাই তোমাদেরকে. So screenটা first of all curved হইতে হয়. So we'll see very soon why the screen needs to be curved, right? So you need to use a curved screen like that. And what you'll notice is that the pattern that forms here is very similar to the pattern we had seen earlier. মানে যেটা হচ্ছে তোমার double slit interference হয়, but instead of double slits, how many do we have here? Millions of them, right? So what's the final outcome? So final outcome হচ্ছে এই স্ক্রিনের মধ্যে we see some spots গুলো এরকম দেখতে হবে. So if I take red light and pass my red light through this, right? If I red light pass করি, the red light passes through this diffraction grating, right? And it forms these spots on the screen. So মাঝখানে you'll find like a very bright spot, okay, like the central maxima. But interestingly, pashe is full darkness, and it's dark for a very long time. By the morning, large distance is fully dark, and then again, what shows up? The spot, and then again it's dark, and then again the spot shows up, and again the spot shows up. এরকম করে কিছু spots দেখা যায়. These are called orders. So আমরা ওই যে আগে বলতাম না maxima for the double slit, এখানে we call them order. Okay, so what you notice is that the light will produce like a central order, তারপর এদিকে একটা first order produce করে, একটা second order produce করে, একটা third order produce করে, এরকম করে order produce করতে থাকে. Bright spots গুলো বলা হয়, right? Now there's a derivation for this, like why does it happen and why is there darkness in between, right? We don't have this, but just try to understand that it's a similar principle as diffraction rating. Diffraction rating double slit can interference with it because the path difference was multiples of lambda. এখানে same টাই হচ্ছে, but a million of them have to match to create a maximum. Do you understand what I mean? And a million waves should come and hit a point where all of them produce a path difference that's what? A whole number multiple of lambda. Can that happen very often, or will that only happen at very certain specific spots? Very certain specific spots. That's why we have like very few of these here. Okay. Anyways, not our concern. Our concern is to understand there's a bright spot here. এখন কোয়েশ্চেনটা হচ্ছে, so what's in it for us? মানে এটা ভালো হলো, we get it, right? But why are we learning this? Turns out this particular device, right, has a very far-reaching use in science. কি করতে পারে এটা? Turns out if you take a light source that's a combination. What do I mean by combination? It's like a mixture of many different colors of light, right? For example, the tube light here. So the tube light that you see here, I mean, it's obvious what color is it? White, right? But do you know it's not the full spectrum? Full spectrum মানে কি? Right? Violet, indigo, blue, green, yellow, orange, red. এটা যদি use করো, এটার মধ্যে দেখবা যে red missing, এটার মধ্যে green missing. But what else is produced, like available there? Violet, indigo, right? Yellow, orange. ওগুলা mix করলেও it appears what in color? Whitish in color, but not what though? White. And you'll understand the difference in this. আজকাল খুব easily বোঝা যায় because of LEDs. You'll find there are like 3 types of LED out there. There's something called a cool LED. Like the color to bright blue hoy. Then there's this warm LED. They go to yellowish color hoy, right? And then there's this neutral LED. যেমন এই রুমের মধ্যে this one is a cool LED. This one, don't you say it's a little bluish in color? But আবার দেখবা যে ওইটা হচ্ছে cool LED. It's very bluish in color. আবার দেখবা মাঝখানেরটা is like a little yellowish. Now it could be because it's dirty, I don't know, but it is little yellowish in color. Okay, so the point I'm trying to make is that there are different variants of it. And how do you create variants of white out there? By adding and removing certain colors in it. So যেটা warm হয়, ওটা থেকে কোন কালারটা রিমুভ করে ফেলা হয়? Blue. And I don't know if you know, your phone has this night mode. It turns all yellow, right? So it removes what from your phone screen? Blue color, right? Why? Because blue hampers with your sleep cycle. So blueটা বাদ দিয়ে দেয়, right? আবার তুমি হচ্ছে দেখবা যে হচ্ছে বাসার টিউবলাইট গুলো ছবি যদি তুলো, like you take a camera, like the normal camera, and take picture, everything is a little bluish, right? Cannot, because there's too much blue light there. Our eyes can't pick it up, unfortunately. Our eyes get used to it at the point বুঝে যাচ্ছে না. But if you actually see this room through like a device that can capture light, the way this room is fully blue right now. It's just it's little whitish blue. Okay, now point right? Point হচ্ছে আমি এত কিছু বললাম because আমি জানি দেখে বলতে পারলাম, but can you look at this and tell me what colors are there? No, right? When it's just white to you, wouldn't it be very difficult for you to judge what's there? So আমরা যেটা করতাম আগে, I don't know if you know, there's something called a prism, and you pass a white light through the prism and it splits up, and it's called what? Dispersion. ওইটাই করবো আমরা, but dispersion এর প্রবলেমটা কি? The dispersion is very subjective. কেন? ওই white light একটা রেইনবোর মতন প্রডিউস করবে, এখানে কোনো মেজারমেন্ট করার কিছু নাই. All you know is that white light can be split up, right? This thing is an advanced diffraction dispersion mechanism. See what happens, okay? So when the mixture of these colors go through, they will produce spots as well. So দেখবা যে লাইটটা বেসিক্যালি কি হয়ে যাচ্ছে এখানে? স্প্লিট আপ হয়ে যাচ্ছে এভাবে. So light splits up and forms these spots on the screen. And it turns out, if we take proper measurements from the screen, we can actually find their individual what here? Wavelengths, which you couldn't find where? In a dispersion and a prism, right? So why is this important for us? A idea that it is for us to filter out light or find out what are the light colors available in the mixture of light. And I can take a naam dash. I don't know if you caught what the name actually means. Do you know what a grater is? Vegetable grate করে, cheese grate করে. So what do you have? You have this like lot of holes in it, and then you take your food across it, তারপর কি slice হয়ে বের আসে না? This is a grater for what? Light. So as light passes through it, what do? You slice up the lights into their what? Individual wavelength. Okay, so it's actually reversing the process of combining the light, and এটা খুবই helpful হয়। এখন বুঝবো না, but A2 থেকে you learn chemistry-তে flame test থাকে না? Flame test এর মতন একটা test use করি আমরা to find elements, right? It's called an atomic spectrum. ওইটাতে এটা লাগে। So ওই atomic spectrum এ কি হবে? তুমি যখন flame test করো, for example, potassium, what is it? Lilac, right? But ওটা কিন্তু lilac না, it's actually blue, green, and violet এর একটা mixture. A blue, green, violet থেকে separate করতে হয় to understand what the element is, right? ওটার জন্য what do we use here? A diffraction gradient. So this is the origin of its use. So আমাদের syllabus কি লাগবে? Our syllabus wants us to understand the math behind this, and the math is pretty straightforward, to be honest. দেখো কি হয়। So আমরা top view থেকে setupটা দেখবো। So from the top view, when you look at the setup, you'll find that there's the diffraction gradient here, and screen যেটা use করতে হয় has to be a semicircular screen. And the reason behind that is a bright spots গুলো can go to a maximum angle of 90 degrees. মানে এই যে লাইট যে স্প্রেড হচ্ছে না, এই লাইট গুলো অলমোস্ট সাইডে চলে যেতে পারে। Do you understand what I'm trying to say? So if the light can go to the side, don't I need a screen that covers everything? So what kind of a screen would be appropriate here? A curved screen, right? So semicircle use করা হয়। So এরকম একটা থাকবে, and you take your light source, whatever light you are trying to split up, right? And you pass it through this. And as the light passes through this, right, the mixture, light taking shape pass through করে, as the mixture of light passes through, what you'll notice is it'll go and form bright spots. যা বললাম। So যে এখানে একটা bright spot হবে, এদিকে একটা হবে, এদিকে একটা হবে। Now if it has more colors in it, it'll produce more of them. Now also interesting জিনিস একটা, and important for you, it produces a pattern that's symmetrical. দুই দিকে একই জিনিস form হয়। Okay, so what if I had green here? তাহলে যে স্ক্রিনের মধ্যে you'll find that green form হচ্ছে, but greenটা একটা separate জায়গায় form হয়, not at the same place. And that's very important for us because that's how we figure out what their wavelengths are. So yeah, this is what the pattern looks like. এখন আমাদের যেটা করতে হবে is figure out how to find the wavelength here. That's what we are here for, right? So these are called orders. এই যে bright spot গুলো এটাকে order বলা হয়, and the central order is called the zeroth order. So this is the zeroth order. So it's basically central. Then you have your first order. Order is represented by n. Small n is the thing that we use for order. Order is maximum. This is like just so you can maximum to confuse na kora jonno ekhane order bola hoy. You have your first order here. Then you have your minima to ekhane kaje deয় na, so we don't have a name for minima here. Order and the third order. What's the maximum number of order possible? Depends on the light. So blue jono 5 hote pare, setup dependent. Okay, so different setups can produce different number of orders out there. Right. Now the angle ekhane jeta is very important. So how much it deflects is very important in our math. And the angle that we measure is actually the angle from the center to the order. So এটা 1 হয়, আমার second order angle থাকবে, but that's what we do. Okay, so order হচ্ছে point হয়, and you find the angle, right? So এগুলো সব combine করে come across formula. I'll get right to it. So formula is a very interesting topic. The formula is d sin theta equals to n lambda. And this equation will help you find the wavelength of the unknown light that you are observing. So what do we want to mean to explain? First of all, theta to বুঝছো কোনটা? What is theta? The angle between the central zeroth order and your first, second, third order. So whenever you take the angle, you take the angle from where to where? From the center, okay? And because the formula is so obvious, ওরা তো এক্সামে যখন হচ্ছে ট্র্যাপ করার চেষ্টা করে, right? Trap by giving information like this, যে এই অ্যাঙ্গেলটা দিয়ে দিবে বা ওই অ্যাঙ্গেলটা দিয়ে দিবে, right? আর এটাও দিবে, so you need to figure out which one is the right one, and the right one is always the one from where? The center, okay? So that's theta. n টা কি হবে? n টা হচ্ছে order number. So for example, আমি যদি হচ্ছে second order টা ইউজ করতে চাই, আমার n এর ভ্যালু কি হবে 2 আর theta কি হবে এই thetaটা, right? So our aim at the end of the day is to find what here? Lambda. So our lambda বের করার জন্য there's one more quantity that's missing, and এই quantity একটু ঝামেলা করে, it is d. d-টা কি? So d is the size of the lines in the diffraction grating. So our diffraction grating এর lines থাকে না, ওই lines গুলোর size কত, gap এর size কত, that's d. Now how do you find that? So ওরা যেটা করে, ওরা d কোনোদিন দেয় না. I have not seen them give d ever. ওরা যেটা করে, ওরা বলবে that the glass that you bought, right, মানে diffraction grating glass, contains 1 into 10 to the power 6 lines per meter. A information to provide for me. Okay, 1 into 10 to the power 6 lines per meter. What does that mean? The 1 meter of this glass will contain how many lines? 1 into 10 to the power 6. Can I use this information to find the size of one line? Yes. If 1 meter has these many lines, one line would be what? Key use করতে হবে, unitary method, right? So eventually যেটা হয়, এটাকে আমরা n রাখি, by the way. Eventually d is equal to 1 by n. And তুমি যখন এটা এখানে বসায় দিবা, once you put everything in the equation, what do you come up with? The wavelength, okay? And that's the purpose of the diffraction gradient. So diffraction gradient main cast of tricky to take a light that has been combined and split it up into what? Their individual wavelengths, right? Why is this better than your prism? It's much more precise. Prism এ কিছু করার নাই, measurement নেওয়ার কিছু নাই. Prism can only tell you that the light can split up, but it doesn't give you values to work with. This gives you values to work with. Okay, so yeah, that's your diffraction grating. আমি একটা নোট দিয়ে দিচ্ছি এখানে, একটু কপি করে নিও, but তার the more importantly, tell me if you have any confusion. What do we see if we pass white light through it? What do we see? মানে এখানে যদি একজনের কোয়েশ্চেন হচ্ছে এখানে যদি হোয়াইট লাইট পাস করি, what would I see? The spectrum. Where will I see the spectrum? Like, will I see the spectrum all over the screen, or will I see the spectrum? Yeah, so তুমি স্পেকট্রামটা এখানে দেখবা, এখানে দেখবা, এখানে দেখবা. The spectrum will form in all those places, okay? 3 different places. In the middle, it'll be white, because the central is basically a combination of all the lights. So in this central, that's why the central is not part of our calculation either. So in this particular diagram, the center will appear like this green thing that you see here, because it's just straight line going through, no diffraction, nothing happening. Vertical screen. So if your screen is like, oh, okay, like flat screen. Yeah, you will. But the problem is the ones on the side, they'll be like smudged, because the screen is getting stretched out. So what's happening is that those will spread over. And what does that lead to? Inaccuracy. Because I need them to be very fine points to measure my angle, right? Once they blur out, right, it becomes difficult. That's why a curved screen ensures that all of them travel the same distance. Hence, they produce a very prominent bright spot everywhere. It's the size of the line. So yeah, I'll explain what it means. So let's say these are the lines here. These are the gaps, right? These are the gaps. D is the size of the gap. So each gap, the size. Now the thing is that we can't really measure them properly. So what we do is we take the total length and we divide by the number of lines, and that will give us a very close value. But actually, D means the size of the gaps individually. Because the angle doesn't change. Because at the end of the day, see the values we are using here, right? If you take your screen further away, right, would they form at a larger angle or same angle? Same angle. Think about this, sorry. আমি যদি হচ্ছে স্ক্রিনটা দূরে নিয়ে যাই, angle same থাকবে. What will change between them? Spacing. Then spacing is not part of our calculation, right? So আমার স্ক্রিনটা যদি ধরো hypothetically speaking is somewhere here, like that, right? এটা এদিকে যাবে, এটা এদিকে যাবে. What is the angle still? Same. But what is different on the screen though? They're very wide apart, right? Which doesn't hamper my calculation, because my calculation doesn't rely on that information. Okay. So yeah, even if you take it far away, it's not a problem. So what would be better, to keep them close? and if you keep them close, then it's much more brighter, because the further you take away, they get dimmer. Okay. That's a good question. I think answer kori do green spots form below red ones because their wavelength is higher? Yes, এই জিনিসটা একটু আমরা ম্যাথ করতে গিয়ে observe করতাম. Like, what would be the sequence of the colors? It'll be sequence based on the wavelength. So red has the longest wavelength. So will you find it at the largest angle or the smallest angle? Red has the longest wavelength. Equation to karo. It's you don't need to think much. Red has the largest wavelength, right? So amar je spread hoye jacche na, will it form at the larger angle end or the smaller angle end? Smaller. Larger. কেন এই যে দেখো d sin theta equals n lambda. Lambda বাড়লে theta বাড়বে. Theta বাড়লে মানে কি তোমার red will form at the bigger angle. তারপরে তার পাশে কি আসবে? Orange, তার পাশে কি আসবে? Green, তার পাশে আসবে হচ্ছে violet. Violet would be the closer one. So এই স্পেকট্রামটার মধ্যে red দেখবে দূরে থাকবে আর violetটা হচ্ছে কাছে থাকবে. Okay? তারপর question হচ্ছে d is the size of the gap, right? D কেমনে বের করতে হয়? 1 divided by number of lines per meter. ওরা এখানে ট্রিক করে কি, ওরা they'll say number of lines per centimeter, number of lines per millimeter. So তখন conversion and students lose marks. So be careful about that. Meter নিয়ে যেতে হবে. Is theta equal to 2 times theta 2? Oh no. No. So it's not evenly spread out. So if you find the first angle is 10, the second one might be 27. The third one will be something else because it's a sine theta function. So the way it changes is not linear. Does the brightness decrease as the order increases over here? In this particular scenario, no. Cannot, because am I not using like a semicircular screen? So isn't the light travel in equal distance everywhere, right? So no. Is the angle between successive orders same or does it change? It changes. So first order take a second order angle, second take a third same na. So be aware of that. So if they give centimeter, then we use, yeah. So if they give you in centimeters, my recommendation is first find it in centimeters. Like, 1 centimeter gives you this and whatnot, and tapo convert to meters. Okay, it'll be easier that way. Bigger angle than greater n. So wouldn't lambda decrease? Bigger angle, greater n. No. So I'm saying for the second order. So order is fixed. So bigger wavelength will give you a bigger angle. What does that mean? Is that, do you see there is red here? I could have drawn red on this side or I could have drawn red on that side. So the question is, would red be on this side or should red be on that side? The answer is the red should be on that side, because for the same order, red will have a bigger angle compared to green. That's why red would be on the further outer end. I can do violet thakto, violet would be like closer end because it has the smaller angle. Okay, so I'll give you some notes on this copy now, and then we'll do the math. Mainly তোমার ইকুয়েশনটা ভালো করে বুঝতে হবে, that's all. There is done. We can then practice questions. Okay, so the formula is the main thing here, d sine theta equals to n lambda, okay? So I'll be giving you 2 questions to try out. These are based on what we've done so far. So therefore, but you'll find plenty of these in your past paper. However, a diffraction gradient is almost always just for paper 1. I've seen paper 2 very rarely. Paper 2 does it, but not as much as paper 1. Paper 1 only does it almost every year. Okay, try this. This is very basic. A light passes through a diffraction gradient contained in 1 into 10 to the power 5 lines per centimeter. A bright spot is generated as a third order with an angle of 60 degrees from the center. Find the value of lambda. So screen, diffraction gradient. Light passes through like that, and first order, second order, third order. The third order forms at an angle of 60 degrees from the center. That's 60 degrees there, and that's it. So that's the third order. Find the wavelength. Uh, 10 to the power minus. Yeah. That's it. 2.89 into 10 to the power minus 8, right? Right. So how do we do this? D sine theta equals to n lambda, and d to be equal to this. So it says 1 into 10 to the power 5 lines per centimeter, right? So 1 into 10 to the power 5 lines in 1 centimeter. I want the I need to know the size of the one line, right? So one line would be x, which is I'm going to find out. So you need to use this. So x is equal to size of one line is 1 by 1 into 10 to the power 5. So that's 1 into 10 to the power minus 5 centimeter. But I need the answer in what meter. So therefore x is 1 into 10 to the power minus 7 meter. So that's the value of x, right? So you got the value of x here, which is d 1 into 10 to the power 7 into sine 60 equals to n is going to be 3 because of the third order, right? So that's the level of 0.899 with 10 to the power minus 8 meters. Okay. Right. Now let's try another one. I mean, if you're wondering, does it get very difficult from this? Not really. It's just eğitim öğretçi ediyor correct. Right, try this. A wave of 420 nanometer passes through and generates a bright spot. Find the total bright spots on the screen. তোমার হচ্ছে D দেওয়া আছে, so তোমাকে বের করতে হবে স্ক্রিনের মধ্যে the maximum number of bright spots possible. Okay, আমি একটা জিনিস বলে নিই before you try this math. What if your bright spot যে নাম্বারটা n ক্যালকুলেশন করে আসছে 4.99? What should your answer be? Yeah, so what I'm trying to say is this, okay? Our maximum number of bright spots, so center take is 0, then you have 1, then you have 2, then you have 3. তারপর তুমি একদম maximum edge এ গিয়ে, what is the angle that produces the maximum? 90. So আমার theta টা কত নিতে হবে to find the maximum? 90, right? 90 করে আমার n এর ভ্যালু আসে 4.99. So what should the maximum number of bright spots be? 5 or 4? 4, because 90 তে যদি 4.99 আসে, 5 কি কোনদিন দেখা possible? 5 wouldn't be less than below that. So 90 is the maximum diffraction possible, right? ওইখানে যদি 4.99 আসে, that means the last bright spot you could have seen is the fourth one, and fifth one তার possible হচ্ছে না. Okay, so just keep that in mind. So yeah, ওইটার উপরে base করে দেখো তো এটা পারো নাকি. That's some few points here, like important things to keep in mind when doing this math. This is one of those rounding down বলে এটাকে. Twenty-three. On the career, yes, 23. That's for you to decide. What do you think? So what should the answer be? 23 or 47? 23. Acha, okay, করে দেই. 23 যদি আসে, that's very good, because that's on the way to the correct answer. So d sin theta equals to n lambda. Our d হবে হচ্ছে 1 into 10 to the power minus 5. Sin কত নিব to find the maximum spots, 90, equals to n is the order number, which is what we're trying to find out, times lambda is 420 nanometers, so into 10 to the power minus 9. So once you put all of these together, কত আসে? 23 point something. 23.8. Yeah, so 23.8. But because you can't see 24th one এখানে কোনোভাবে, because you took the maximum angle, right? So it should be 23 orders, right? So 23 should be the answer. There's a question here, why did you take the angle as 90? Because 90 means the light has refracted or diffracted the most, and that's the maximum number of spots possible, right? But the thing is, this is not the answer though. So it says find the total bright spots on the screen. Screen ki half hoy na full hoy? Full, right? So what should it be? Yeah, 23 into 2. But that's not the answer either. Why? Because there's a central spot that doesn't count in our math. So the total number of bright spots on the screen would be what? 23 on this side, 23 on that side, plus the one at the center. Yes, 47. Yeah, 23 plus 23 plus 1. Yeah, 47. Okay. So yeah, maximum number of bright spots. (23 into 2 plus 1, 47. I'll add here, can এটা করতে হচ্ছে, so into 2 হচ্ছে, since screen is symmetrical, and spots form on the other side. And এটা হচ্ছে central right. Okay, right. So আমি কিছু important points এখানে add করে রাখতেছি। এই chapter প্রবলেমটা হচ্ছে these are the points that they test you on. They're not really part of the syllabus per se, but they are things that you learn while you do the math. যা দেখালাম, for example, এরকম. So I'll add these kind of points here. So number one হচ্ছে to find the value of b, we use the total number of lines in the given length. The maximum number of order can be found Okay, so question হচ্ছে isn't there other 23 spots below? No, so above 23, below 23, yeah. তারপর মাঝখানে একটা 1. So that will be 46. So there's a question here. When we find the maximum number of spots after multiplying the number by 2, why do we add 1? Because then we find and we accounted for number of spots in the 0 to 90, so aren't we supposed to subtract 1? Oh no, so the thing is, why did we add 1, right? So the math that you do here gives you the number of bright spots on a side other than 0. 0 that obviously show করে না. So you'll have like 23 lines on this side, right? Which means you'll also have 23 lines on that side, excluding the center. But since the question is the bright spots on the screen, so you'll have 23 on this side plus 23 on that side. That is how much? 46. And then the bright spot at the center is the straight line, right? So that's one more extra. So what's the total number of bright spots here? 47. So our math never takes into account which bright spot? 0. N0 has pura math 0, right? So our math starts on the first bright spot. So ওটার পর থেকে হয়তো, so ওটা যেহেতু ignore করা হয় math এ, when they ask the total number of bright spots, we just have to add that to the total number out there. Right, so আমরা next class হচ্ছে আশা করি, so I'll not be doing the questions here. আমি আগেও বলছিলাম, I just want to get done with the syllabus. I'll be starting electricity next class, okay? So once you're done with everything, we'll do all review questions that are out there. End of this month, hopefully. Just electricity is left.